Today we're going to be talking about the distance formula and the midpoint formula. Okay, they're two formulas for geometry that you're going to need to know, but they are based on the coordinate grid. The distance formula is the top of these notes, and it's already written here for you. The distance between two coordinate points on a coordinate grid is measured by the square root of x2 minus x1 squared plus y2 minus y1 squared. And what the distance does is it tells us how far is one point from another. So if it asks you how far away are two pieces or 2 points on a coordinate grid, you're going to be able to answer that question. For instance, what if we have the question, find the distance between the points 3, -7 and 0, 3. These are not things that we can just put on a number line and find the distance between, okay, like absolute value was. No, these are going to be on some sort of incline. So we're going to have to use this distance formula to find the distance. The first step that you want to do is label. And when I mean label, I mean we're going to go, this is x1, this is y1. This is x2, and this is y2. So similarly to when we were finding slope, you're going to label the coordinates. Oh, that should say y2. Yep. The second step is to plug it in. So if I have the distance between 2 points measured to be the square root of, this is this formula over here, open parentheses x2 minus x1, close parentheses squared, plus open parentheses y2 minus y1, close parentheses squared. Yes, these parentheses are important because you are subtracting a negative number. Don't just mess up and put the wrong thing down there. You do need double parentheses there. Okay, so then we would go to our calculator and we would calculate the distance. Okay, you can plug this in right now. So step 3 is to calculate. Put it in your calculator. To get the big square root, what we would do is we go to the square root button right above the x squared. See the square root, it is blue, so we press the second button before we press that. And you type it exactly as you see it, all of the parentheses included. So we have parentheses 0 minus 3 close parentheses squared plus open parentheses 3 minus open parentheses -7 close parentheses squared. See that double close? We got to do that. And if we calculate this distance, we would answer the question by saying the distance is approximately equal to 10.4 units. See how I rounded that number to the nearest tenth? In geometry, you will have to round correctly, and you will have to put units at the end of it. It did not tell me what we're measuring, so we're just going to put the word units. That is the distance in units between these two things on a coordinate grid. Easy peasy lemon squeezy. If you can throw it in the equation right here, label it, plug it in, and throw it in your calculator, you're good to go. The second formula we're going to learn about today is the midpoint formula. Okay, the midpoint, since it looks like the word middle and then point, it is literally the middle point between two other points. Okay, and we find it by taking the average of the y's and average of the x's. So to take an average, you add everything up and divide by the number that there is. We're just going to add up the x's, divide by 2, and add up the y's, divide by 2, to find the average between those, which gives me my midpoint. So the question they might ask you for this is, what coordinate, this time it's not a distance, what coordinate is right in the middle of the other two? They might ask you that question. So we're asked to find the midpoint between the points 6, 2 and -8, -4. All we have to do is, similar to distance formula, is label things, plug them in, and calculate. So step 1, we're going to label x1, y1, x2, y2. Labeling, done. Step 2 is to plug it into the formula. So we know that the midpoint, or the middle coordinate, can be found by taking x1, 6, plus x2, which is negative 8, and dividing that by 2, and by taking y2 and adding, y1 and adding y2, and dividing by 2. Essentially finding the average of both points. Okay, we do each of these pieces separately in the calculator. So get the fancy fraction, and we would do 6 plus parentheses negative 8 close parentheses all divided by 2 to find out that the midpoint's x-coordinate is negative 1. Then we do the y-coordinate. Fancy fraction, this is 2 plus negative 4 divided by 2, which happens to also give me negative 1. So we would say that the midpoint between these two coordinates on a coordinate grid is the average of those, which is negative 1, negative 1. If we graphed it, we'd have the coordinates 6, 2, and negative 8, negative 4, and this number right here, this 1, 1, negative 1, negative 1, would be right in the middle of those 2 points. Now, both of these formulas actually come from Pythagorean theorem. The following part of your notes you do not have to write down, but you do have to watch. Okay? If you find what I'm about to do very interesting, engineering might be your calling, because engineering does a lot of what's called deriving. So we are going to derive the distance formula. Again, you do not have to write this down, but just watch. Okay? So let's say we have some triangle on a coordinate grid, or 2 points essentially, and this point K, and then we have this point Q. We want to know the distance between those 2 points. Now, I can't just count, like it's not just like it went up 3 and it went over this. No, I want to know this distance. If I draw in the triangle that this creates, this becomes a right triangle. Now, what we know about right triangles is Pythagorean theorem. A squared plus b squared is equal to c squared. If this were A, this would be B, side A, side B, which means this hypotenuse is side C. A, B, and C. Now, we want to know what C is. Okay, we are going to isolate the variable c. To do that, we have to get rid of this squared. To undo something that's squared, you take its square root. And what I do to one side of the equation, I have to do to both. So this c squared, if I take its square root, all that's left is c. And then I have the absolute value of a squared plus b squared, since I did that to both sides. Now, what we know about k and q is that k can be some coordinate x1, y1, and q can be some coordinate x2, y2. Just any coordinate. Okay, we want to know a squared's distance. So if we know what a is, which is just a straight line, that's the units 1, 2, 3, 4, 5, 6, 7 in this particular example, until I get to the next x squared. Look, it's the same x value on these two, and it's the same y value on these two. So this corner point actually has the coordinates x2, y1. If I find the distance of a, all I need to know is how far apart these are. So really, all I have to do to find a is take x squared, or x2, and subtract x1 away from it. That's the distance here. In this case, it would be 7. Okay, this coordinate minus that coordinate would tell me how long this a side is. Similarly, I can do that for b. If I subtract y1 from y2, I would know how long this short distance is in part of my triangle. So I can substitute, instead of saying side B, I can say, all right, why don't I just subtract y1 from y2? and that's still equal to c. Now, wouldn't you know it, we have started with Pythagorean theorem. looking at properties of a graph, we have arrived at our formula. We have arrived at our distance equal to the square root of x squared, or x2 minus x1 squared, plus y2 minus y1 squared. So Pythagorean's theorem actually gives us the distance formula. Isn't that cool? Okay, we can also derive the midpoint formula. Similarly, if I have some graph, okay, and two coordinates on this graph, like here, this is going to be the coordinate 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. And then if I have the coordinate 1, 2, 3, 4, 5, 6, 7, 2, 7, 2. Okay, I want to know what coordinate happens to be right in the middle of this line, between these 2 points. I want to find its midpoint. It's going to be like somewhere right here, but I really want to be accurate. I need to figure out where it is. Okay, again, if I create my little triangle, you would notice that this corner piece right here is the coordinate 3, 2. The x value from the first one and the y value from the second one, just like it was in distance. Okay, I want to know what these two pieces are, halfway between these and halfway between that, because that creates my midpoint. This is the average, or halfway between 3 and 7. What is halfway between 3 and 7? If you don't know how to do that, you would just take the first number plus the second number and divide it by 2. Or in this case, 3 plus 7 divided by 2 gives me 5. That's the part that I had. That is the x coordinate here. So we already have the first part of our midpoint formula. We know that between the two of them, if we just average together the x values for both points, we'd end up at the right spot on the horizontal axis. That also works on the vertical axis. Here's the first point 2, it's at height 2, and then this one's at height 5. What's right in between 2 and 5? You find that by adding them together, taking their average and dividing by 2, which is really y1 plus y2 all divided by 2. So there again, we found the second piece of our midpoint formula. We have derived it from things that we know about graphs. In this particular case, since we've taken the average of both, 2 plus 5 is 7, 7 divided by 2 is 3.5. So our midpoint here, if we're actually doing this example, would be the coordinate 5, 3.5. That would be right in the middle of the 2 points we started with. So deriving formulas is really fun. You're taking pieces of things you know, things about graphs that you know, and creating more formulas from it. Before you leave today, make sure that you glue your note page into your spiral. The title is G2-distance and midpoint. Okay, this goes right after your absolute value notes.